Excuse me. Hello. Hi, the Center for Integrative Environmental Health Sciences and Department of Pharmacology and Toxicology welcomes you to our Environmental Health Science Series seminar. It's my pleasure today to introduce Dr. Charlie Zhang. Dr. Zhang got his Ph.D. from the University of South Carolina at Columbia in 2006, and he is currently a professor in the Department of Geographic and Environmental Sciences and also holds a faculty position in the Department of Urban Planning and Public Affairs. He also holds 2 editor positions, one as a review editor for the International Journal of Applied Geospatial Research, and another as a associate editor there, review editor for Frontiers in Sustainable Cities. He is a health geographer with extensive experience in environmental pollution, health disparities, urban demographic analysis, and crime mapping. And specifically, he's been involved in projects looking at environmental pollution and ovarian cancer, exposure to heavy metals in coal ash and children's neurobehavioral problems, lead poisoning or childhood blood lead poisoning, and cancer disparities in rural Kentucky. His funding sources include the NIH, the NSF, the American Cancer Society, and the Kentucky Cabinet for Health and Family Services. And he has had many publications in journals like the Air Quality Atmosphere and Health Applied Geography and Environmental Pollution, among others. And so with that, I will hand it over to Dr. Zhang to talk a little bit about his current and ongoing research in coal ash from coal-fired power plants. Here. There you go.
I'm very grateful to CIEHS for providing me this opportunity to talk about my work, my research in the field of exposure to coal ash, located near the coal-fired power plants in this nationwide. We're all familiar, right, with the coal ash and the coal-fired power plants, especially in Kentucky. It's a coal country. And actually nowadays still 70% of the electricity in Kentucky is generated from coal-fired power plants. Although nationwide it just had dropped to less than 20%. So today I'm going to talk about my work on 2 projects actually. One is about the connection between exposure to coal-fired power plants and birth defects. The second one is about the proximity to coal ash storage facilities and the connection with the cancer. Both of them are, we use a national data set. So, in general, right, historically, coal-fired power plants was the primary source for generating electricity. But in recent decades, the percentage of coal-generated electricity dropped dramatically. And because of the environmental protection movement and the efforts made by government, public to transition to more renewable, clean energy. So you can see like less than 20% nationwide. And worldwide, however, it's still pretty high, it's 37%. In some countries, especially the developing countries such as China, India, they are building a lot of new coal-fired power plants. That's just definitely raises concerns for environmental and public health. So what is the coal ash? I think the last month, right, my colleague, collaborator Lonnie gave a talk about the project we work on. That's actually, we focus on the 2 coal-fired power plants in Louisville area and how they might be connected with children's neurobehavioral problems. So coal ash, right? Coal ash is the major probably, like for coal-fired power plants. when they generate electricity, they burn coal, right? To produce steams and make electricity. So the byproduct, that's called coal ash. It's also called a coal combustion residue. That's the name used, the term used by EPA or CCRs. For over 100 years, right? Because the first coal-fired power plant started second half of the 19th century. And every year, this country produced over 100 million tons. And now it dropped to like below, like a 70 million tons. That's the second largest waste, right? Industrial waste, just next to mining industry, right? Mining. The major concern is the heavy metals and the radioactive substance contained in coal ash. And after burning, right, coal to produce electricity, the coal ash actually contains much higher level of concentration in terms of heavy metals and other toxic substances. So next question, right, where the coal ash storage facility is located? So geography definitely matters, right? Because the coal-fired power plants, they want to save transportation costs. Most likely, they will directly dispose the coal ash, right? That includes fly ash and the bottom ash to directly in their property, right next to the power plant. According to the Earth Justice, right? Earth Justice is a nonprofit law organization. They did a lot of work research to count how many, right? How many the coal ash sites are located across the country. That includes many, the power plant closed down, not operating, but still the coal ash sites, landfills, ponds, impoundments are still there and still cause environmental problem and the public health problem. Like nobody exactly know, right? How many? Like 1,400, right? 1,400. Probably that could be undercounted. So where they located, actually, we all know coal-fired power plants are most likely located near the river or lake, right? Or because they access to fresh water to actually to burn the boilers, just create a streams, right? And also to cool down, right? Cool down the waste. Therefore, actually, they stored in landfills or ponds. Most of them are uncovered or online, right? That uncovered means that they can blow away, right? Or if it's rain, like a heavy rain yesterday, storm, right, will definitely cause the toxic, right, containing in coal ash to actually blow into air or leach into the rivers, lakes, especially to the nearby neighborhood, right? Most likely the low income, the minority dominated neighborhood, who are next to very close to coal ash and the power plants. So this diagram shows actually how the environmental impacts from air, water, and the solid, right? Solid. So actually, this is a map actually produced by the Earth Justice. This map shows actually, look at the black dots, right? The black dots shows actually online units. Actually, you can visit this map and to see how many, right? How many CCRs in the affiliation with each coal-fired power plants, like Mill Creek in this area, which is the largest one, the 6 of them, right? Many of them are online. See, the green ones are online, right? Many of them are online, you see. Of course, right, coal ash storage landfills can easily cause natural disasters like the ones we all know. 2008, Kingston, TVA, the Tennessee Valley Authority operated, right? That's actually the splash. The spill of coal ash, actually, it cost over $1 billion for the company to clean the coal ash, right? And actually, many workers who participated in the cleaning of the coal ash, actually, they developed diseases, including cancer. Many of them died, like over 30 of them died. They filed a lawsuit against the contractor. They won the lawsuit. Actually, just last year, they settled down the lawsuit, actually. So this picture shows coal ash, the spill of coal ash, and the picture shows the Kingston, the fossil plant located in the east of Tennessee. about 40 miles west of Knoxville. Oh, actually, just 10 days ago, another one happened. 5.5 million gallons of wastewater spill from coal ash near the plant, right? Near the Twin Cities, in the Minnesota. That's actually the natural disaster, actually. So what about the government regulations? For long times, coal ash was not regulated by the EPA until 2015. Actually, 2015, EPA released the first CCR rule, coal ash rule, actually to require coal power plants to clean the coal ash ponds, clean the coal ash landfill. Basically, you cover them if you're not covered, or put liners below the coal ash pond. Actually, just this year, right? EPA April this year, EPA finalized the coal ash rule. Basically, they're going to require all the coal power plants to clean the coal ash ponds, landfills. That include many of them. They were not counted for the first time, right? Because they were not operational anymore. They were old legacy ponds. They were polluting the air, polluting water, and polluting the nearby neighborhood. That's definitely it's a good thing, right? We hope this kind of rule can be reinforced, right? Actually, this map shows also made by the Earth Justice, which shows the regulated and not regulated. You see the red ones are regulated. The pink ones are actually legacy only, which means they were not counted in the 2015 rule. All right, there are many of them located in Kentucky. We are among the top 4 states, which have like a 68 landfills or coal ash ponds, right? That's the picture shows actually this one on the Ohio River, the Mill Creek. That's the biggest one, right? It produced like 1,700 megawatt electricity. It's a good.
They were all muted online. There's nothing. Ah.
Oh, there's somebody. Okay.
Oh,
yeah, let's go. Yeah. All right, sorry about that. So actually you can look at the how the coal ash, right, pollute the groundwater, right? This is actually satellite imagery showing data collected by Ash Tracker, who collaborated with the Earth Justice. They collect samples, right? Groundwater samples for hundreds of actually wells located nearby coal-fired power plants. So this one shows Cane Run, right? Cane Run actually converted to natural gas in 2016, located right next to the rubber town, right? In this area. The red dots actually shows samples for heavy metals. Here you can see the list of what kind of heavy metal: arsenic, mercury, lead, you name it, many. They exceeded the standard actually, and so the red ones are actually cause the groundwater contamination. This one shows the data for the Mill Creek, right? The red one shows actually samples which exceed the EPA standard. Actually, for example, for arsenic, right, it's 37 times higher than the standard, the EPA standard. That's how bad, right? Because right next to Ohio River, think about, right, how the pollution, the contaminant will affect larger areas in the lower reaches of the river, right? So actually, I just look at the data, right, released by EPA. I look at just for Mill Creek, because Mill Creek is the largest coal-fired power plant in this area. You see the picture, right? How big the smokestacks releasing the pollutant to the air, and also the chart. I made this chart actually show the recent years, the data. How Mill Creek, these are company reported data. That means can be higher. The data can be higher. So 2018 to 2022, you see the orange bar, orange column shows actually on-site land release. That's the major part, right? That's actually over 10,000, right? This is for lead, right? Heavy metal lead only. I just look at the EPA release data, chemical sheet. And actually for air release is much smaller, right? Air release much smaller. For the land side, that means coal ash, right? Coal ash fields That's tons for lead. And I look at the data for arsenic, right? It's over like 10,000 pounds, right? Actually each year from a Mill Creek. The existing literature, right, on this topic have suggested, right, as we all know, exposure or proximity to coal ash or coal-fired power plants can actually be related to birth defects, cancer, low birth weight, respiratory problem, neurobehavioral problems, gastrointestinal disease, so on. You can name a lot. Right? However, a very limited study, right? Limited study have actually looked at the coal ash, right, released by coal-fired power plants. Zeroy, right, and colleagues, right? Actually, I was on the team, received funding from CIEHS a couple years ago. We looked at the linkages between proximity to coal-fired power plants and neurobehavioral problems for children, right? For children, actually, we published a few articles. Lonnie was on the team, and actually, basically, we found a kind of a correlation. Of course, correlation doesn't necessarily imply causation, right? The children who live near the two coal-fired power plants, Kenron and Mill Creek in Louisville area, they actually showed much lower performance in terms of neurobehavioral test, and much higher, right? Much higher concentrations in their toenail and fingernails, right? That's basically we collect data for 250 children, toenail and fingernails, right? To see how the geographical clustering and their connection with the neurobehavioral problems. All right, next I'm going to talk about the two projects I'm working on right now. They're not published yet. It's an ongoing project. The first one I'm going to talk about actually the correlation, right, between the birth defects, right, birth defects and coal-fired power plants and the coal ash, right, the geography. As actually what CDC reported, right, the birth defects is actually very common. Actually, 1 out of 33 babies born have a kind of different type of birth defects. I mean, worldwide can be even higher. We don't exactly know actually what caused the birth defects, and therefore some scholars suggest it's definitely important to look how environment, right? Environment play a role on the birth defects. So therefore, actually, we're working on exploratory research to try to see how the power plants, right? Location of power plants might be related to high level of birth defects nationwide, right? Nationwide. So we use the CDC released the data on birth, right? With the birth defects identified. And we look at the data released by EPA, the toxic release inventory, especially we isolated the coal-fired power plants to see their spatial relationship. Definitely, this kind of research is helpful. Ecological study to try to identify the uneven distribution, right? Uneven distribution for TR toxicants, right, and the birth defects. So the natality data released by CDC was from the Wonder database. Actually, basically, you can get a county level, right? County level summarize the number of birth defects cases. We just lump all types of birth defects to look at how many birth defects cases, right? These are actually originally from the birth defects, right? Birth defects, CDC collect data. We all know birth certificate, right? Birth certificate actually can easily undercount, right? Undercount the cases for birth defect. That's kind of a limitation of the CDC released data. And also for counties which have a small population below 100,000 people or less than 10 birth defect cases, they will be suppressed. That's the policy to protect confidentiality. So therefore, we get a sample of 568 counties. Also, we account for the other confounding factors. So the the EPA data for exposure, right? We look at like about 300, right? 300 coal-fired power plants with the minimum capacity of 1 megawatt. Specifically, we use the EPA. Recently, EPA released the air toxic screen. Many of you are familiar with the NATO data, right? That's National Air Toxic Assessment. But now, actually, from last 2019 and 2020, EPA just released. From this diagram, you can see actually how the EPA, right, model to estimate the dispersion, right, and building concentration for the areas surrounding the facility, right, toxic facility, including coal-fired power plants. They calculate the concentrations, and also they calculate the toxicity, weed, cancer, risk score, and some other types of diseases. So that's actually the data. We actually, EPA actually released the data for every sensor check, like sensor check level. And for the most recent 2020 data, actually, they actually estimate the concentration for each block. Our value was understanding the details about the. So actually, this map shows this map to show the 2020 data was released actually with the couple months data, which shows you can see actually the uneven distribution of this is for arsenic, right? Arsenic chemical. They're very clear, right? Very clear. Look at that legend, right? And look at the lowest value, highest to the highest value, like 30 times long. That's very interesting. Look at the Louisville area, right? And the Robert Town, or Robert Town. You can see west end, right? Western part of the county, much higher arsenic where they're from, right? So actually, this data actually account for the, just for air toxic, right? We don't know how much from the ash piles, right? The coal ash ponds, right? They leads into the groundwater, right? That can be, can be even more, right? I definitely just don't know. Very difficult to measure, right? Difficult to measure how the soil data, right? All the river stream data, that's water exposure. Right? So we use the GIS, right? Geographic information systems, right? To look at to investigate the distribution of sorry about that. Just not used to that. Okay. Sorry. So for birth defects, we calculate the odds ratio to see how the counties, right, close to coal-fired plants and the control group, right, which are far away from the coal-fired power plants. And then we run regression models to see how the proximity to power plants and the birth defects, so this actually this map shows the you can see the 568 counties with data for birth defects and the locations of coal-fired power plants. Pretty much actually, the kind of northeast and Midwest, right? They have the highest, largest number of coal power plants. The western part of the country, you can barely see much, right? Coal-fired power plants. So the odds ratio results show actually we tried several different types of distance threshold, because we don't know exactly how far, right, the contamination, right, from coal-fired plants will impact the environment, the nearby neighborhood. We tried 3 kilometers, 5 kilometers, and 8 or 10 kilometers basically. So for the counties, they have a power plants inside the boundary or nearby within 3 kilometers, within 5 kilometers. That considered the exposure group. And for the beyond, right, which means they don't have a power plant of 3 kilometers or 5 kilometers away, that's the control group, right? So the odds ratio was 1.23 actually to 1.24 for kilometers, and it's kind of significant, right? Significant high for the. I made this chart to show actually you can easy comparison. Nearby counties and far away, right? Far away actually consistent disparities between these two groups, indicating right potential connection between exposure, pollution, the health impact right, of coal-fired power plants. The regression model actually shows supportive results. We also these are variables, right? The covariates we include in the model, like a BMI, mother's age, and number of prenatal visits during pregnancy. So the distance to closest coal power plant shows actually significant, right? Negative correlation, that's reasonable because the larger the distance, the actually the lower, right? The rate. That's what we're expecting. The ambient exposure to arsenic significant. Manganese significant positive. Selenium, which is radioactive, that's significant. Actually, we have to exclude the like lead or mercury because they highly correlated with arsenic and with some variable. We try to avoid multicollinearity, right, to make the models more reliable and solid, right, solid. Summary for the first project, right? Basically, we found kind of expected results indicating connection between proximity to coal power plants and the burst defects, right? Burst defects measured by county, especially the kind of the EPA air tox scores, ambition. Ambient concentrations are positively correlated with the burst defect rate. Of course, we have to realize, right, acknowledge, that the ambient concentration for arsenic and other heavy metal actually that include all the everything, right? Everything release the toxicants to the air, not only the coal-fired power plants. That's a limitation, and that's a limitation. But we all know, right? Coal-fired power plants, they contribute the most, the largest, actually in Kentucky, 90%. 90% air pollution caused by coal-fired power plants. Definitely, that's good to know. Right. The next thing we're working on is about what about the cancer, right? Because we know heavy metal cause cancer related to cancer. We just look at the correlation, right? Look at the correlation. So that's actually we want to look at coal ash, right? Not because actually many coal ash ponds and landfill are still there, polluting the air, the environment, although the power plants are being shut down, right, for many years. But the coal ash actually, the health impact persists for a long time, right? For a long time. That's why EPA actually just updated the EPA rule, right? Want to include all the landfills, all the coal ash sites, right? The data we used for cancer was from the CIEHS, right? Database cancer registry. Actually, most of the states, right, have a cancer registry program, including Kentucky, pretty good one. The data on coal ash was from Earth Justice. Actually, they counted the number of CCR units nationwide. We use the air toxic screen assess the cancer scores. That's actually how the EPA, right, in the model, they calculate the risks based on lifetime exposure to each chemical toxicants, right? And then they calculate the cancer risk for each. This is very amazing for each block, very small block, right? That's actually the. Okay, first this map shows the over 700 coal ash storage facilities. Many, right? Many the coal-fired power plants, they have multiple, right? They have multiple these kind of units, right? These kind of units. So this is actually based on the 2020 air toxic screen data, actually county level. We aggregated data to county level to show the cancer risk scores, right? Cancer risk scores. It's kind of very, you can actually have a website, online mapping web page you can visit, right? You can download, you can look to the kind of cancer risk scores for every block. This across the entire country. This is for the 48 states, right? The southeastern part of the country, actually, and the west coast, they have the highest, right? They have the highest cancer risk score, right? Cancer risk scores, which is like about 9 times higher, right? Lowest versus the minimum, the maximum, right? Maximum. What about the cancer incidence, right? The SEER cancer registry data, the annual average, right? Average annual incidence, right? This incidence, we look at the incidence because we want to, because mortality, right, can be related to many other demographic, right, insurance factors, right? So it will be actually more, make more sense, right, to look at incidence every year from 2016 to 2020. This is actually the latest data released by CDC. 5 states don't have data, like Indiana, no data, Kansas, Nevada, Minnesota don't have data. So, but all states, right? 45 states can have still. Look at Kentucky, right? Look at Kentucky, actually, we all know we rank with the top, right? With the top in terms of the overall and the lung cancer, right? And some others. That's definitely, so this is not surprising, right? Not surprising. We created hotspots, right? Hotspots and cold spots. Definitely Kentucky, right? Kentucky, West Virginia stand out, and also Illinois, because Indiana doesn't have data, right? If the data there, our Indiana our place and the CIEHS, right? CIEHS side. So the western part, that might surprise you, right? Look at the west, southwest, right? They have some coal-fired power plants, but no hotspots, right? No hotspots. This is basically how the geospatial statistics should run, right? To compare, right? Compare the data for each county, compare with the national average to see significant differences, right? And then that will be identified as the hotspots or cold spots, vice versa, right? Vice versa. Then we look at the statistics, right? Statistics, basically for the top left chart shows actually all size, right? Cancer, all size, all ages, all gender, for counties. Over 2,000 counties, that's definitely good, right? Good enough. We only have 3,000 counties, over 2,000 counties of data from CIEHS, right? From CIEHS, that's definitely reliable, right? For the counties which have a CIEHS size or they are close, right? 5 miles, 10 miles, 20 miles. We did a comparison, which is look, you can see how big the difference, right? It could be as high as like 800, right? 800 incidents for cancer per 100,000 population. And it was below, it's like 550, right? That's 200, right? 200, over 200 per 100,000 population. That's the difference. And the differences are consistent, right? Consistent. If you change the threshold buffers, and then that's to try to control the sensitivity, right? Sensitivity. Then I look at the data for lung cancer alone, because we on kind of a lung cancer is more directly, right, related to exposure to CIEHS, right? To CIEHS, that actually you see lung cancer actually that's for 5 miles, 10 miles, and 20 miles, right? 20 miles is definitely, right? Definitely it means something, right? It means something. The regression analysis, regression models just shows the kind of preliminary results. Actually, 2,660 counties. That's probably like 80%, right? 80% of all the counties in this whole country. The first variable that's actually we want to test, right? If counties which have CIEHS facility or nearby, less than 10 miles, that's actually the dummy variable used. Very significant, right? Positive correlation with the cancer risk. Cancer score, that's actually the EPA estimated based on the pollution, right? Pollution level, concentration, exposure modeling. Very significant, positive. Also, we control the smoking, right? Smoking rate, that's from the data provided by CDC. County level, smoking rate, Kentucky, that's another factor, right? Obesity, that's another factor. Some research suggests, right, related to cancer. Socioeconomic determinants, right? The poverty rate actually, unfortunately, very surprisingly, it shows negative, right? That's I don't understand why the poverty shows the negative correlation. For all cancer rate, it's like a 16% variation explained by these independent variables. For lung cancer, actually, we get a 42%. 42% of lung cancer variation across the 2,600 US counties can be explained by this regression model. Especially the two, right? The two factors we want to look at. Proximity to CIEHS and cancer score. So the summary for this project, right? Second project, we just kind of like the preliminary, right, correlation, test our hypothesis about potential linkages between CIEHS facilities and cancer incidence. So therefore, definitely, right? Definitely, findings, right? Results like these can provide insights, right, into what caused the cancer, right? How we can prevent, right? How we can reduce, right? Mitigate, right? Cancer incidence rate across the country, right? To shed light on policies, right? For environmental protection and public health policy. So ecological fallacy, right? That's definitely need to be addressed, right? Because aggregated count data for the both cancer rate and exposure, right? And exposure. Another limitation is actually in this model, it's very difficult, right? We don't have data. It's difficult to account for the exposure from other sources, like from water pollution, right? Solid, ponds and the landfills, right? Definitely it's hard to measure, right? How to measure. Therefore, actually, that's the EPA air toxic screen, right? They model airborne, right? Airborne pollution only. Definitely in future, right? For future research, we can do more, right? Do more to understand more about the connection, right? The mechanism between exposure to CIEHS and all kinds of diseases, including cancer. So we can measure, we get samples, right? We get samples, air samples, water samples, and soil samples, right? Soil samples to get more measures, right? More measurements. And the community-based study definitely can help, right? We can get a more precise data because nowadays, right, NIH, right, highlighted the importance of precise measurements for exposure and also for the health outcomes, right? Health outcomes, instead of using county level data or aggregated data to other geographic areas, that can cause bias, right? Cause bias. And some studies, they have used the kind of mobile devices to let the patient, right, recruit participant to let them carry mobile devices to get them all-time or real-time exposure, right? Instead of just based on your residence or based on your working place or whatever, you can all 724, right? Get measures. That's very good, very helpful. Of course, lastly, accounting for environmental justice and climate change can be important, definitely, to improve health equity, right? And to help the people, the residents, communities who actually suffer the environmental impacts, health impacts the most, right? The low income, the minority dominated neighborhood, right? That's basically why we do research, right? Basically, this presentation, I will be grateful to get comments and suggestions, right? We can do better, right? It's a good opportunity for me to learn from everybody. As many of us know, right, actually, including EPA, CIEHS was not regulated until 2015. And even the 2024, the final rule, EPA has not recognize the coal ash as a hazardous waste. That's actually definitely we need to do more research, right? To educate the public, educate the policymakers to know, right? It's very poisonous, right? It's hazardous, right? And it lasts a long time. Even the coal ash, the power plants shut down, right? Actually, this country, we probably most of the coal-fired power plants are going to be shut down. We have schedules, right, to reduce or transition to natural gas or other renewable clean sources. But the coal ash plants are still there. We're gonna have a long-lasting impact, right? So that's definitely important. In the literature, there are existing gaps, right? Existing gaps in terms of the mechanism, the connection, right? Between exposure and coal ash, right? Coal ash. So therefore, we definitely a lot of work to do, right? Future research is imperative, right? To thoroughly investigate the detrimental health impacts of pathogenic, right? Coal ash, right? Coal ash. This is the actual last slide I'll show you. Actually, we live in a world. Actually, many countries, developing countries especially, they are still building tons of coal-fired power plants. According to the data released by Global Energy Monitor from their website, 14,000 coal-fired power plants. Right? They are. I mean, worldwide. Right? Worldwide, definitely worldwide is a big problem. Right? Pollution here can easily blow to other places, other countries, other continents. Right? Cause global-wide environmental problems and health problems. Definitely, it's a big task. Right? Big task. Last slide, actually, this is what geographers, right, or environmental epidemiologists can do, right? I'm from the geography department. We have a center for GIS, right, what we can do. Our colleague, look at the picture, shows our colleagues doing some of the urban heat island testing, collecting field data. Right? We do sampling, right, mapping, and spatial statistical modeling, and evaluating the health risk. That's all I wanted to talk, right? I think my collaborators, the funding, although we were not directly, we don't have a direct funding for this kind of study. So thanks very much. Any question?